Okay, today we're going to talk about the replication part 2, the methods and controls. Okay, before we go through today's topic, we want to have a look at how QP, the query processor, works first. Okay, because this section is actually related to Altibase replication methods that we're going to talk about in a minute, and it will allow to understand Altibase replication methods easier. Okay, the query processor is the main components of DBMS that is in charge of managing all the SQL sentences, and it handles SQL sentences executed by user as following level. Okay, the parsing here it checks all the syntax of the SQL sentence, such as grammar and etc. Okay, and it also checks the spelling, characters, and etc. And once it is checked, it creates a parse tree. Um, and once it is finished from parsing state, it goes to the validation. Okay. Validation process, it checks the validity of SQL sentence, so it checks whether the requested data column, table, and a user exists in the database. And once it's checked, it expands the parse tree. Okay, so once the validation process finished, based on the parse tree made from the previous stage, it calculates the total cost of access and creates the final optimization execution plan. Okay, so far there's these three stages are called the prepare stage, and it is managed by the query processor. Okay, in an execution stage, it runs the execution plan made from optimization level. Okay, here and through storage manager. So we call this a execution stage. Okay, and it is processed by the storage manager. Okay, the execution plan is also called as plan tree. Okay, that is actually expressed as a tree format to process the methods in order and access direction of the query for the most optimized way in DBMS. The execution plan is used in execution process as an indicator of SM. Okay, the storage manager. The storage manager is also one of the main components of DBMS that manages all the saving and management of data through concurrence control and recovery. So it actually executes the execution plan in the end. Okay, so one of the ways to improve the performance of DBMS is to minimize the prepare stage, and there are three main ways of tuning DBMS. First of all, minimize DBMS call. Secondly, minimize the prepare stage, and lastly, reduce the disk I/O. So one of the way to minimizing prepare stage is important part to optimize the performance. Okay, now let's have a look at why it is important and how it is related to Altibase replication methods and the method that is used in Altibase. Okay, so we have just looked at the terms, and now we're gonna have we're gonna have a look at how they're related. Okay, other than share this architecture, the share nothing architecture use the method of replicating data. Okay, so there are many features of replicating methods and depending on its type. Okay, so we can use many ways of replicating data. As you can look at the diagram, there are 6 methods. Okay, there are 6 of them, and any one of them can be used to replicate data to each node. Okay, first of all, you can replicate it through application program. The data from every node become identical when data processing is configured to be executed on every node, not just on a single node. However, this method cannot guarantee data consistency, and there will be high cost for writing application program. Okay, as DMLs are executed on both sides, the local and remote. Okay, unlike executing replication within the database itself, when using application to process replication, it is necessary to write code to ensure data consistency, which makes it more complicated and difficult to author replication. Secondly, the data can be replicated by sending the SQL. So when insert is executed on node A, then same insert statement is sent to node B and executed, and so that the data is replicated. However, this method goes through a prepare stage on both nodes, so there will be a overloading on query processor, and also it will be difficult to find out the replication conflicts. Thirdly, the execution plan for SQL can be sent. The execution plan is the result of prepare process as the SQL sentence is executed initially. The data can be synchronized with the execution plan by running the execution process right away, which is without the prepare process. So when the execution plan made from node A is sent to node B and replicates data, the query process overload can be reduced from node B. However, this method will allow increased network loads due to high volume of transmission. Okay, fourthly, the SQL sentence can be converted after receiving reader log. However, this method will cause the SQL conversion expense, and it has to run prepare execute process again for SQL sentence from remote node. Therefore, there will be query process overload, so that the performance will be decreased. Okay, Altibase use the fifth one. This method replicates data by converting the reader log, and the reader log is formed when transaction finish executing. In Altibase, the reader log is not just sent as it is sent after converting reader log into a form that can run execute process from remote node straight away, so that there will be no query process overload. Okay, this method will allow conversion expense for reader log, but the overload of query processor will be decreased and will guarantee high performance of data replication. This is why the Altibase use this method for replication. And also, it can be converted for any operating system, as it is platform independent, and it can also reduce the network overload, as there is no high volume of transmission. Okay, finally, the reader log is sent without the conversion. For this case, the performance is relatively fast, as there is no conversion cost, but it is not compatible with an active configuration, because the log is used only when recovering. Okay, for example, after service has been shut down. So this method is not performed in real time, so the load balancing is not possible. Okay, so let's have a look at the basic application architecture, how the log is sent from local server to remote server in a diagram. Okay, so from the query processor, actually, once the query is executed from the client, the query processor actually received it, and it does all the parsing and validation and optimization. Okay, and it goes to the story manager. Okay, story manager actually writes the contents to the reader log. Okay, and that reader log actually is read by the sender thread, and sender thread actually makes the X log, again, sends to the receiver thread. So receiver thread receives the X log and sends it to the story manager from the remote server. Okay. As you can see from the diagram, there is no query processor in the remote server. Okay, it just goes straight to the story manager. And then story manager actually writes that contents to the reader log. Okay. And now we're gonna have a look at some main terms using replication. Previously, I said the replication doesn't send the reader log just the way it is, but it does do conversion. Then who and what does this conversion? The sender thread does the job. Okay, the sender thread reads the reader log and converts that into something called X log. Okay, after it is converted, it is sent through network. The reason why doing conversion is because to reduce the query process overload from the remote node that I just received the log, so that the fast replication is available. Okay, the X log is converted is the converted log that does not go through query processor, which means the only the necessary portion of log from story manager are extracted, so it will skip the prepare process from remote node. As a default, on one X log that corresponds to one record is created. The replication is processed in real time, as the X log is created in real time. And the receiver thread from the remote node receives this X log and passes to story manager to reflect the contents. Okay, I want to remember this term, the X log, the sender thread, and receiver thread, because these will be mentioned a number of times throughout the replication topic. Okay. Okay, now let's see how the X log is created as the aspects of SQL sentence. Okay, the X log is not created for a single SQL sentence. X log is created for each single record. Okay, like a diagram, when modification occurs, the three records for C1, that it means the update is executed on three records. Then three X logs for C1 equals 1, C1 equals 2, C1 equals 3 are created. The sender thread actually reads this log, read the log, and converts into X log and sends to receiver thread. Okay, and the receiver thread from remote node passes to story manager, and three records are updated by each of their logs. Okay, so for example, when 10,000 records are updated, the very last 10,000th of X logs are created, and it is sent to remote server, and they will apply or individually. And because the X log is created for each record and sent, well, when multiple records are updated, the rollback can be executed partially or as a whole. Okay, I'll explain about this part on later session. Okay, then let's talk about the replication objects. The replication object is must-have object when configuring replication. The replication is not processed by database to database, but object to object. This is why the object with the same name is created. Okay, um, between Altibase that execute replication, and the replication is done through objects. If the object is created with the name RP object XY in DB1, then this object also has to be used in DB2 as well. Okay, for example, if the object is created with the name YX from DB2, then replication cannot be processed. When creating a replication object, there are some information to be inserted. One of them is IP information. Okay, the IP address of the remote node and the replication port number of the remote DB have to be assigned. If the multiple IP addresses are assigned in DB2, then one or more of IP addresses can be assigned when creating objects. Okay, this is to enable the service without downtime when there's a network failure while replicating by connecting to IP that was previously configured. Also, the table can be assigned when creating objects, because the replication is managed by table units. So even though there are 100 tables in database, only 10 of them can be chosen for replication. Like a diagram, out of 4 tables, only 2 of them are chosen. Okay, the X and Y. Okay, so only X and Y are replicated, and any other modification occur from the other 2 tables are not replicated. The replication table can be dropped or created by using alter syntax even after object is created. Okay, Altibase chooses one of 2 methods while replicating. The first one is called lazy, and the other one is called eager, the sync. Okay, this method can be configured on each object, not on each DB. Okay, for example, if X and Y tables need high performance of replication, then these tables can be assigned in REP object and processed by lazy method only. Okay, the other tables in A and B needs data consistency rather than performance, then these tables can be added in an object called, let's say, RP object underscore AB in DB2. Okay, and these tables can be processed by eager method. So this is how the replication performance and the data consistency are managed efficiently, as replication types or the IP information can be configured depending on the replication objects. Okay, because in start and stop syntax can also be executed by object unit. One object can execute start while other objects are stopped. Okay, and about the columns and constraint that I use in replication, they have to be applied in the same kinds of table, meaning same specification. Okay, I'll talk about this more in later slides. Okay. There are certain rules for replicating tables. First of all, the table must have PK. Okay, as the data is replicated by PK value, the table with no primary key cannot be assigned for replication objects. Okay, the specification for replication tables must be identically matched if either the column name or data type or constraints or column size is different. The replication cannot be processed. Okay, the replication can be processed even though the order of the number of column is different. However, the purpose for using replication is to make the data same, so the order and the number of them have to be matched in order to manage it efficiently. The primary key is necessary for replication table, but foreign key is not. Okay. The foreign key is not available because it will cause inconsistency from active-active environment. Okay, the primary key information for both tables have to be the same. The one thing replication, the sequence is not supported. The sequence is not supported because replication is not processed by tables record, and non-table subject objects such as sequence is not supported in replication. Okay, if you really want to use sequence, then you can create sequence value as 10 to 10, 12, 14 in local, and 11, 13, and 15 in remote server to avoid a duplication error. Okay, the reason why it gets duplication error is because even though the sequence value is inserted in a local server, it does not replicate to remote server, meaning it has to start from the initial value, whatever the value is inserted to the local server. So it gets duplication error because sequence cannot be replicated. Okay, the replication object is necessary for replication. The syntax for creating replication is as following. I said the replication types can be configured for each replication object, and you can do that when creating replication objects. You can choose one from either lazy or eager. Okay, when it is not configured, the lazy is chosen for default. As master, as slave is for the data conflict, and I'll explain about this in a later session with conflicts. The option clause is used configuring the offline replication, so this syntax is optional. You can skip this clause just like as master and as slave option. The with clause is for assigning remote host IP addresses and replication port numbers. With clause can assign multiple addresses, and in from clause, this one, the table is assigned when assigning for multiple tables. Okay, the from clauses can be used. Okay, so when we talking about replication object in previous slide, we can create replication as create eager replication like RP object XY with 192.133.1.1. Okay, for example, like port numbers like 30300 as port number, and from like a.table x to b.table x, something like that. Okay, so let's look at the example. Okay, so this is the example of creating replication objects. Okay, in your local server, the IP address is 192.168.1.160, and the replication port number is 25524. And in a remote server, the IP address is 192.168.1.12, and replication port number is 35524. So you just got create replication and RP1, which is the name of the replication object, with the address of the IP address of the remote server, which is 192.168.1.12, which is the same as this one, and the replication port number 35524, which is this one. Okay, from the name of the schema, sys.employ, the name of the table you want to use for replication, the table from your table from your local server, and the table from your remote server, the sys.employee, and the other table, the additional tables from sys.department to sys.department. The same in remote server as well. Create replication RP1, same object name, remember, and 192.168.1.160, which is the same as this one, the local server. Okay, and 25524, this is the replication port number from their local server as well. And the table is same, the name of the schema and the name of the table employee, and the two, this is actually remote to local and the department as well. Okay, so straightforward. Okay, after creating replication object, the modification for object is also available. The IPN tables can be added or deleted. Okay, for example, only one IP address is assigned when creating replication object. But if you wanna add additional IP address just in case for replication failure due to network problem, you can do this using alter syntax and edit while up. Again, vice versa. If you want to delete the assigned IP address, you can just drop it using drop syntax. Okay. If IP address is not assigned by set syntax, then the IP is applied as the order that was assigned when creating an object. Okay, so the set syntax is used when assigning the primary IP address. So let's say you're using like 10 tables for replication object, and all of a sudden you felt like adding another table. Then you don't need to create another object. You can just add using add syntax and add a new table in an existing object.